Right. This is yet another OpenChain webinar. We're having quite a few to end the year. This one is a bit special. We're going to be talking about the software hash ID, and this is something that comes out of software heritage. We've talked about software heritage before. Essentially, it's becoming a library of software that allows us to understand the whole corpus of what's out there. It's becoming a repository of the software knowledge, and naturally it's critical for open source to have the type of reference, security, and analytics of a centralized repository. Not satisfied with that, though, the team decided to create a way to actually identify what software is there, to help people identify software. And then they went and standardized it, a remarkable accomplishment that has ramifications and ripples far outside of just the Software Heritage Project itself. In other words, we're here to talk about a way that you can identify software with a standardized hashing approach. We have Thomas joining us from Software Heritage to talk us through all of that. Before we get started, though, antitrust policy notice time. This is a Linux Foundation meeting. It's an OpenChain project webinar. At the beginning of every Linux Foundation meeting, we show the antitrust policy notice, and we let you know you can find the full policy on the website. If you're from an LF member company, you can ask any questions of our counsel, Andrew Updegrove. If you're from a non-LF member company and you have questions, you can ask them of your own counsel. Long story short, it's a way to make everyone comfortable with speaking openly together. And talking of speaking openly, Thomas, I'm going to hand over to you to present to us and tell us what is this software hash ID that you lot at Software Heritage have created? Why should we care? And where does this all go next?
Hi, thank you. Thank you for the invitation. So I'm Thomas. I come from Software Heritage. I started this year, so I will be mostly presented work from others, and I will speak about software hash ID or SWID. My presentation today, it will be a few words about the software heritage and the relation of software heritage to SWID, and mostly about the data model of software heritage. Then I will speak about what are the SWID today and some usages of the SWID that you can imagine already do. So a few words about the Software Heritage. Software Heritage, we are a non-profit organization. We claim that we are building the library of Alexandria of software source code. Our mission is to collect, preserve, and share all the software that is publicly available in source code form. We do that because we believe that there is a lot of knowledge from the humanity inside software and that it has to be preserved. So we are a non-profit organization, and it was started at INRIA 10 years ago by Roberto Di Cosmo and Stefano Zacchiroli. But today it's backed by many other organizations. You have organizations from the public sector, from academic, from industry. A lot of people are backing the software heritage. Software heritage is today the largest archive ever built about software. We archive billion of source code files, 26 billion as today, 50 billion of commits, millions of projects, and we do that as one infrastructure and open and shared for different verticals that we want to address. The first one is about cultural heritage. We want to preserve this data and make it as available for the humanity as possible for long term. For industry, we want this archive to be useful for industry. They can build some application around the software heritage. For research, we see ourselves as a kind of telescope about software, so where you can see how software is built and make a lot of analysis about software, and for public administration, because we can be useful for compliance. The data we collect. So the first one, source code files. We today have 26 billion deduplicated source files stored in our archive. We also store the history of source code. We have code revisions, commits if you speak Git, with the date, the author, who makes this change, the message, why it does that, and related file. And several metadata about that from the code itself, for instance, if you put a file named code meta.json inside the repository, or from the ecosystem around. Today, mostly about GitHub. We collect also the stars on declared language on GitHub, but we are trying to generalize that to other forges. We connect release, specific version tagged by developers, packages, a lot of information about the software. We collect that from a lot of different origins. The biggest one is obviously GitHub, but we do that from many kind of forge. GitLab, some SVN forge, SourceForge, Launchpad, Bitbucket, almost everything that you can imagine, we try to collect from. And some of them already does not exist anymore. For instance, Git4use, Google Code, are the mercurial part of Bitbucket has been shut down, and the repository inside may have been lost if they were not archived by Software Heritage. A lot of them have been transferred to other forges, but some may have been lost. So how do we archive? We have written some bots crawling the software forge and translating that to our data model. We have our crawler will connect to all these forges, list all the repositories that we can access inside it, and then they will retrieve for each repository the source code file and the history and translate that to our data model. We can also collect archive from the deposits, mostly from libraries advocating for open science. Open science is an academic movement claiming that for science to be open, you need to have paper published. It's already done in general, but you also need to publish the data and the source code. Obviously, Software Heritage is positioned about source code, and we do that from several libraries. So it's a way for libraries to push some code to the Software Heritage. They can push code from their scientists, for instance. And the last one is a swap, the Software Heritage acquisition process, which is mostly for older historical source code. Think about the code that you may have on a floppy disk in your garage. It's a process to send this software to the Software Heritage for archiving for a long term. And we do that also with some technical gems. The first one is the object storage. We have built an object storage to store reliably those 26 billion files. It's today 1.5 petabyte of data. And one of the difficulty of this object storage, there are many of the other object storage, is that we store a lot of small files. A common source code file is less than around 1 kilobyte. We have billions of files, not big data by itself. It's not big files, but a lot of small files, and we have to work around that. We have a graph compression algorithm also, which makes us able to access to the whole code history from one server. So those 50 billion commits, we can compress them and get them in one big server and make some requests on that to find the commits between two other commits, for instance, or all the files from the commits, or all the commits which affect this file, and so on. And obviously, the suite, the software hash identifier, I will speak more about. So you can browse the archive content at archive.softwareheritage.org, and you can see the archiving code at gitlab.softwareheritage.org, because we believe that such an archive must be as transparent as possible, and we want our code to be open source. So in a nutshell, you have some lister that will connect to many kind of forge, list all the origins, and then you have a scheduler that will trigger that all those origins will be cloned locally inside the software heritage and translating to our data model in the graph, and then all the source code is archived in the object storage. So we have a global development history. It's permanently archived and it's a uniform data model. We map all these kind of forges to one data model. And it's one infrastructure that we share. It's more efficient, it's less waste, and it's a universal knowledge base. So the SWID, it's a software hash persistent identifier. At first, it was tightly connected to the software heritage data model. Today, we have computed 50 billion intrinsic SWID. It's decentralized, it's cryptographically strong identifier in the SWID. So to describe a bit more the SWID, a SWID always starts by SWH. Then you have a schema version. For the moment, it's the version 1, but at some point we are thinking about a version 2. And then you have the object type. Object type is related to the data model. It can be a snapshot. It's a time where software heritage comes to the repository. It's a release, a tag, mostly in Git. It's a revision, a commit if you speak Git, a directory which will contain file, and content, which is a file and description of a file. And then you have the object ID, which describes the file and then you have some context. For instance, you may want to see one specific file in the context of this specific repository at this specific time, for instance. The SWID is an intrinsic identifier. It allows you to identify some code fragments, some files, some directories, some commits, some release, some snapshots. And if you need more information about project version, modules, and so on, you have some other identifier which are extrinsic. So to come back to the SWID, it's a Merkle directed, they are all stored in a Merkle directed acyclic graph. It's a blockchain, but not, if you want, blockchain where you will not get any money. So if you take the content, the SWID of a content, the identifier of the content will be mostly the hash of the content. So if you change the content, its SWID will change. But you can compute the SWID of one content if you have the content. A directory will be the hash of the SWID of the contents inside the directory or of the SWID of other directories. So if you change anything in one directory, it will change its SWID, and you can compute the SWID of a directory given that you have access to this directory. The revision, it will be the hash of the main directory and the previous revision and some revision data. So if you change anything, you will change the SWID of the revision. It's a perfect identifier. And for the release, it's the same. So why intrinsic? Because we want to be easily computable on local files. It allows that to be decentralized. Everyone can compute a SWID. You have no central authority. For instance, you have some other identifier and someone should grant you this identifier. It's a more complicated process and you cannot apply that to almost everything like we do. And it's applicable to your code. If you have your code, you can compute the SWID, even if it's private code. You do not have to share it. You can compute the SWID locally and give it to everyone. And you have some integrity control. It means that you cannot, if you compute the SWID from a file and you change anything from a file, you will change the SWID. The SWID will be different. So if you get an identifier from outside claiming about that, maybe you can change something. Here, it's not possible with the SWID. So the SWID identifier enables you to precisely reference code in regulatory document, for instance. It's stable, it's temporary evidence. You cannot change anything. So in compliance and audit or SBOM, it's really interesting to have this kind of identifier because they are really strong. It's cross-platform. You can apply that to almost everything. It does not depend that you are on GitHub or in specific Forge, for instance. You do not even have to use Git. It doesn't depends on if you have a big repository, a lot of small one. For instance, you can do whatever you do and compute the SWID, and it's tooling independent. Today, the SWID is normalized. So it brings me to SWID today, and the big news is that it became an ISO standard. SWID, in fact, is no longer owned by the software heritage. We have built an open and transparent and collaborative and vendor-neutral governance and become an ISO standard this year. So it defined a standard that we do not own anymore. The SWID is now free to use from anyone, and we have defined the governance. The governance, so we have some bylaws that they are detailed in the governance document. It's consensus-based decision-making, and it's an open process to produce an approved specification. We have a license about the specification and about the contribution. You have to adhere to an open license. We have built a GitHub organization around that, a mailing list, and we have already a core team responsible for the governance of the SWID project with different kind of role. The maintainers who will schedule and lead the meeting, report, educating new participants, and editors that will ensure that everything is done according to the standard defined inside the governance and the bylaw. Some usages that you can do of the SWID. The first one, you can compute the SWID. It's very efficient. You cannot generate your own DOI, for instance, or some identifier easily. You can compute locally your SWID. So, for instance, you just have to pip install the software heritage SWID computation tool and then identify the SWID of a content inside your repository. You can compute the SWID of a given Git repository on everything with this tool. If you have a SWID, you can retrieve the code back from software heritage from a SWID. For instance, I compute the SWID of one piece of code that I have written a long time ago, and then I get this history. I get access to this file in this context because, in fact, this file was stored on Bitbucket Mercurial and was lost, disappeared when Bitbucket stopped its Mercurial services. In fact, it was stored, it was compiled on GitHub, but I can get it back in the context of Mercurial. And you are backed by software heritage. Software heritage, we already archive 26 billion of source files from millions of origins. We have a strong coverage of the open source software, and we have many mirrors, so it's built for reliability. We have mirror in a different place in Europe. We have mirror or copy of the archive in different cloud provider. We have a lot of redundancy for reliability, so you can be assured that at some point the file will stay inside the software heritage. So the code is available at the software heritage as a kind of backup. You can also use the software heritage to find the provenance, find origin of a source code, for instance, on where origin this source code appears, or where is it described or used, for instance. You can, if your code is not archived, of course, it can be a closed source, not yet archived, but you still need to reference it, for instance, for audit, for complaints. Obviously, you cannot retrieve it from software heritage, but you can still refer to it with its SWID. You can compute locally the SWID of what you want to reference. You can put link to it and maybe make it archived at some point if you want it to be inside the software heritage. You can get some information from a suite also. The question is, does the software heritage know my code? So we have built a small tool, an open source tool that we call the scanner, which is open source on open data, and it can be used to scan your source code and is backed by the software heritage. So the idea of the scanner is a small CLI that you can run, and you will run it on your repository. It will compute the suite of all the files of each files on directory inside the directory, and then it will ask to the software heritage, do you know this code or not? And then at the end, you get a web UI or dataset about your code. So the design is that the software heritage act as a source of truth about the public code. With the graph and the suite, we get a very efficient way to get this information. You get file level granularity, and then at the output is a source tree partition into known or unknown file. For instance, I've run the scanner on a personal repository. It's open source, but I alter it with a malicious file. So what does the scanner told me? It told me, okay, I know 7 of the directories among the 8 directories, almost all the file, and some information about the scanner. What it tell me, I can see my code, and here it put a green label on everything that is known by the software heritage, and a gray label about something that is not known. So on a file known by the software heritage, I get the file name, the type, and the suite of the file name. I get a potential origin of the file name. It was a Debian package, for instance, and I get some information about it, some metadata. If I click on a file that is not known, obviously it's not known, so I have no provenance information, but I still get a suite. I can compute this. This can be really useful to know is a code known by software heritage. Maybe you are using open source code, and maybe you do not know that you are relying on source code, on open source code. It would have implication about your source code, maybe. Maybe you are using open source code, you already know that, but one of your dependencies has been altered. It has been modified. Someone put a malicious file inside it, and it's not the dependency you think you are using. So it can help you to find this kind of code. Maybe it's a private code, and you do not want to know that. Maybe we know it. It could mean that someone has put your private code on the internet. If software heritage knows it, almost everyone can have access to it. And maybe it gives you also the guarantee that your dependency is archived for long term and guaranteed access. So you can rely on the software. You can say and tell that your dependency is accessible in the long term through software heritage. It can help you for the complete corresponding source compliance. For instance, the GPL requires that you provide the complete source of the software that you share with someone. Potential story is that you build an amazing software and start to deploy it and share it with someone. You compute all your source code, you put a tarball at release time in URLs on your website, for instance, and it's included in user manual. Then you have a reorganization. Your company change of name. The website is rewritten. And now you have change in URLs. You are out of compliance. Another approach that we propose at the software heritage is to still prepare the tarball, use the deposit to send us to software heritage. You will get a suite back, and then you know that the the code will be stored for long term, and then you can include the suite in user manuals to still get references to your code accessible for everyone. You can also use that in SBOM. For instance, you have a lot of part of a SBOM which will include some references or description of a specific software. And many of those descriptions can be replaced by a suite and will be more precise if you use a suite. For instance, the name of a package with a version, it's something which is kind of fragile. The version is defined by someone. Maybe it's not exactly this code. It can be changed and so on and so on. So with a suite, you can be really precise about this, and you can use that. For instance, in Cyclone DX 1.6, maybe you can replace this information. In the vulnerability section, you also have some entries that could be sorted with suite. For instance, you still describe versions on package information. Maybe you can describe that using a suite. It will be more precise and easier to reference after that. And also in SPDX, you have some reference information, and you are already computing some checksum. Here it's MD5, but a suite is a kind of MD5. In fact, it's a SHA-1, but you already compute some checksum, and you can replace that with a suite. Now that knowing that it's really precise, it's really efficient to link to a piece of software or to a specific piece of software, and that is normalized today with an ISO standard. Some incoming features that we are building now. We are thinking about AI compliance. For instance, you may want to describe the data set that you use during a training, and where, as a software heritage, building tooling to generate some data set for AI training, for instance, using our data. What we want is that people using data sets that we provide reference all the suite of the file that they have used during a training. It will allow everyone to see, does my code has been used in this training? And am I okay with that or not? Or is the license okay with that or not? And with the suite, you describe the file at a specific version. You can already list all the suite. It will be a lot smaller than the whole dataset, and it can be a way to be more transparent about the data that you were using during the training. You can also use that in we are thinking about using it in security. So we are building a mapping of the vulnerabilities, all the CVE that you can find to the software heritage known suite. So in the CVE, the vulnerability description, you often have a fixing commit where the vulnerability has been fixed, and an introducing commits where the vulnerability has been introduced. Sometimes it's not that precise, but we can already compute the suite of both of those parts and detect and allow you, for instance, to detect if you rely on vulnerable code, because with the graph, we can say, okay, all those commits beyond this and beyond that are vulnerable to the vulnerability. And with the scanner on the suite, giving us the suite, we can tell you, okay, maybe you have an issue with this kind of vulnerabilities. About licenses, we are running a large-scale license detection on the software heritage known suite. So we will rely on Scan OSS, and we'll run it on all the data that we have at the software heritage. So we will have some license detection run on almost everything, and with a known suite, you can ask, or maybe we will have the data that, okay, this suite is detected by this software in this kind of license. We are also building a new suite computation tool, which will get a more open license. Today it's GPL, so it can be complicated to include that if you are not using a GPL license. So with an ISO standard, we believe that we should write, for instance, a BSD or MIT suite computation tool so that everyone can use it easily. And it will be easier to use, I think, because there are some drawbacks in our suite computation tool. Some default are not what you would expect. For instance, you have to check about the modules or remove the .git repository and so on. And then we will work on to improve the provenance detection to allow you to find maybe the most pertinent provenance. For instance, today, the provenance detection will give you a potential provenance, one place where it is found, but not the most obvious one, or not the latest one, or not the first one, and so on. So, thank you. You can help today the software heritage on the suite. You can first embrace the suite and try using it and compute some suite or use suite to reference your source code. You can develop or help us developing the tooling you need by coming to talk with us. What do you need about the suite? You can participate in the governance. Yes, we have defined the governance. It's now separated from the software heritage, but it's mostly about from people for the software heritage, and you can help us with the current functionalities and continue archive and help us continue archiving at the software heritage. Thank you very much. Here are some URLs that you can check about Suite Software Heritage on my email if you want to contact me, and if you have any question.
I am sure we will have questions. I've seen a lot of talking in the chat. The first person I'll call to the table is Mattia, because it was the last question in.
Yes, it's exactly that. It's from ScanCode. Sorry.
Just what we'll do is let's redo the context of the question for the watchers, because on the recording they won't know the context. So what is the question related to precisely?
It's about, I think it's about license detection. And the question is, we use ScanOSS or ScanCode, and we use ScanCode for license detection for the moment.
Okay, I thought so. I think I thought I heard ScanOSS, and that sounded like an interesting.
I have done the confusion. Sorry.
Yeah,
So
yeah, no problem.
Yes,
It's confusing names. Thank you.
That's fantastic to know. And scan code is used a lot. For instance, Foslight over in Korea uses it. It seems to be one of the de facto things. We had a notice from Thomas, who had to leave the call, that he didn't know about the Python scripts yet. So he's going to look into that when possible. So it seems that the Python scripts that you flagged are something that people will be interested in and might need more visibility. So hopefully we can perhaps help with that. I mean, it's gone from a database with web access to now something we can call in other ways, which is a remarkable accomplishment.
Yes, but we have a lot of work to do about those scripts to make this more usable. So that's why we are rewriting some part of them, and I'm not doing a lot of publicity around it. But yes, they're available. We have some documentation on the website. We have our GitLab, and we publish that on PyPy, for instance.
That's great. I'm just scrolling down. a note from Mattia that ScanOS is primarily a code duplication scanner, while ScanCode is a license scanner. Hence the choices. Now, there was a question in about your slides. Are some of your slides going to be available? Apparently, Mattia wants to steal your pyramid infographic comparing SWHID, DOI, Wikidata, and so on.
I will share the slide after the meeting with you. There is no issue. I have to check about this pyramid, but I think it's on a lot of our slides, so you can reuse that easily.
That's fantastic news. One of our favorite things in the open source community is to hear that we can potentially reuse material. So I wanted to touch on one question on my side, which relates to the AI thing. So AI compliance is something that's only bubbling to people's attention right now, but we've been working on it in the OpenChain project for almost 2 years. We just released an AI system bill of materials compliance guide. Now that's not an SBOM format. It's a process guide saying that if you're dealing with AI, if you happen to have SBOMs related to AI, here are some process management approaches that can benefit an organization. The fact that you're potentially filling out an area where you can describe data sets used during a training fits into another aspect of the compliance there that's immediately interesting. Who do we talk to about that? For instance, do we follow up with you or someone else at Software Heritage to learn more?
Yes, you can follow up with me. It's part of a big project that we are working on inside the Software Heritage called Code Commons, where we are building a kind of a dataset factory where some people can come and ask us, maybe I want the code in Python, Golang, C++ updated in the last 2 years with this pool of licenses used in this field. And I want, I don't know, 500K file of that. We have a statement that we want people who will use our data to fill. One of the part of the statement is that they have to be transparent about the source, the file that they are using from us inside their training. So the idea is that we give them the list of the suite, and they have to publish this list of suite of the file that they use for their training. Some other part is to be transparent and share the model weights, for instance, and we also want to participate in working group about describing your preferences about using AI or not, or the use of your code in AI or not.
Right, that makes a lot of sense. Now I see Steve has a question. Steve, would you like to ask direct?
I can do, yes. I mean, you're suggesting that we could do scanning using your CLI to do lookups of source code, identify them using the software tag and so on. If many organizations did that at scale, then obviously you'd get a heavy load on your system. Would you be having business models with different tiers that provide bandwidth requirements and things like that?
Yes. In fact, today, if you use a scanner or some of our tools, you will quickly reach some rate limitation because we have a small infrastructure, and we are still thinking about how to monetize that and how to make the strongest access and more available access for people who have a lot of needs about that. Maybe we can discuss that. It can be interesting to see. We also have some issue. For instance, we have some people who do not want to get the suite of their code outside of their organization. They have strong compliance issue, and they cannot even give the SHA-1 of the file they are using. And we are thinking about way to make this usable for them, maybe internally or on their own system, for instance.
Okay. Thank you.
Right. Does anyone else have a question?
I have a follow-up on this topic.
Go for it.
There's so this is a very valid concern, and I was thinking the same as Steve was. If we can just stop paying all the other tools and just spam software heritage archive, which is obviously not the best idea at scale. But there's this other project called Clearly Defined, which has been a bit dormant lately, I guess. But from what I heard through the grapevine, it's going to be rebooted a bit. So there's going to be some more activity there soon-ish, maybe. So would that be something where it could be interesting to plug in software heritage? Because it could work as kind of like a cache of software heritage IDs. So instead of spamming the software heritage archive directly, it would first go through clearly defined servers, and then if it's not there, it could go to software heritage. Just a brain fart. I don't have any idea if this is
maybe
works,
but I'm not aware of people that clearly defined and how they work. Today the scanner is relying a lot on the graph for its computation, so it requires a big server with some hundred of gigabytes of memory on some CPU. But we have also a lot of questions about making the data as fresh as possible, for instance. We have to check with them if it can be a good solution. But we still are thinking about the business model about this, how we can get some money and make it as usable as possible without impacting the first mission of software heritage of archiving and storing the source code. We have some ideas also to deploy that on a different cloud provider and make this access paid, and we will have more control about how to how we pay for the infrastructure and what is the price of the infrastructure and what it costs, rather than what is the price of 10% of one server inside our infrastructure, which can be complicated to define and make this access paid, for instance.
I saw an interesting note from Steve that with some licenses like GPL, there's a source provision obligation between the provider and the recipient. So, the company sends out some binary code. They also have to provide source code. And he was just saying he can imagine a question arising. Could we use SWHID instead of providing the source code, because potentially the software would be in software heritage? And he noted it would be nice if FSF could provide some guidance on this in the future.
I know what Steve thought, but I can raise my hand here on this one because I would say yes and no, and a big no. Why? It's just basically with all the current laws, even European Union and CRA, in the case that, for example, there's an auditing happen on your company, it demands that you have the source code in-house. So if you go to the auditor and says, "Oh, this is my hash ID, the source code exists elsewhere," it's a no-go. It's completely bad for you, and then. So yeah, you can have her completely for this as a checksum and guarantee that the source code you have it really match the what is existing, but it's not enough. You need to have the source code not there at in-house. No
I agree
option.
at the moment. It would be great if the industry and Free Software Foundation could help avoid every single organization having to duplicate the entire GitHub archive.
But this is unfortunately is the law. And for example, let's go to the CRA case. Who sells the software is the liable about the content on there. This is the basic in general what CRA says. So if you go there and says, "Oh, I hired the Linux Foundation to keep the keys of my software," no, they don't have anything because this is between me and Linux Foundation, not between me and the public that I sold the product. So unfortunately, for what we provide, we need to have a copy anyway. It's good to have validations, and now I think that is very, very important. But anyway, we need, unfortunately, to have a copy internally.
Right. And I see Ninjoji-san is unmuted. Do you have a question, Ninjoji-san? I don't hear any audio from Ninjoji-san, so I'm not sure. Okay, I'm going to wrap us up with one last question, which comes from something that Augustine mentioned, which is that Software Heritage has a membership program. Is this something that helps Software Heritage get funding and support? Is it something that we should start sharing with companies as they begin to use your outcomes?
Yes, we have a membership programs. We have different level of engagement and what it brings to company. Yes, it's a way for company to fund to give funds to the software heritage. We have already several companies inside this program supporting the software heritage. It can be by it's mostly giving us money every year, and it's a strong part of how we make the software heritage sustainable.
Well, that's good to know, and especially if we see corporate pickup of using your
Yes.
activities. Oh, Ninjoji-san, we can hear you now. Or we can't hear you. We can't hear you. There's a lot of sound, Ninjoji-san, but we don't have your audio. Augustine made a comment that SBOMs can become manageable if instead of putting all the info into a document, you put SWHIDs and refer to the information on your site. Steve said, do you have an example you can share? Augustine, perhaps you could enlighten us on this approach to using SWHID.
So in this in the slide deck, Thomas show how you can reduce the amount of information you have in your SPON with software hash ID. Remember that one of the object types it's a URL. So for those of you who are familiar with extrinsic identifiers, just like Perl, you can create something similar with your hash ID. So you can also point to a place, not just software heritage, but even a different place. So that means that you can provide a set of software hash IDs and point to where you have all the information stored. You obviously would need to somehow build a kind of a command line tool that do that translation. But if you take a look at the existing tool from Software Heritage, you will find how they do it through the API, and you can build that yourself. If we think about how automotive is working on today, and the amount of information and the amount of documents they manage for S-bombs, I don't think that's gonna work at full unless we find a way, like we did with the source code, right? At some point, we we have the mandate to provide the source code, but now you can also provide URLs to a place where you can download the source code, right? So it would be something similar for the SBOMs. So I'm not saying it can be possible today, except for Software Heritage that has already built it, but it's something. They build it with open source. You can see the API, so you can use the same approach for your own SBOMs. Uh, there's nothing technically that forbid you or there is strong friction to do that at all. So what I envision is that at some point the SBOMs will be a whole bunch of identifiers from not just from software but from other kind of artifacts, and you will have all information associated to it. Yes, you can ship it in documents, but you can also have a place where you can actually manage that. And you just need to guarantee the one-to-one, and intrinsic identifiers are currently the best way we have.
That's a really good point, and it's very useful, Thomas, to have this screen showing us with Cyclone DX 1.6 how that could be approached. It feels like we're on the edge of something here. We're on the edge of a new approach where not just open source tooling is available, not just SBOM formats, and not just process guides, but an identification method that hooks into the Library of Alexandria for open source. That suggests we might have the most comprehensive approach to software management available, and it's open, which is interesting. Thomas, well done to you and the team for making this happen. I know that for us on the outside, it seems like, oh, so there they did it. They were just copy pasting software, putting it together. Nice job. But I talked with some of the team, and I understood that the setup of this, the databases, the sharding, the infrastructure, the ways to search it, getting to the point of exposing public APIs has been an outstanding enterprise effort, something on the scale of open communities rarely achieving.
Yes, it's a lot of infrastructure, a lot of work, and a lot of fight from Roberto and all the members of the team, and it brings some really interesting application after that. So we have the first mission of archiving and sharing and preserving everything, but the share on all we are thinking about a lot of application around that, and several one are a lot of them are interesting because it's really big data set or big database with a lot of knowledge, and we're also thinking about way to gather more knowledge about the software inside it.
Absolutely. And I notice as a side note, we just had a question in from Steve. He wanted clarification. The NTIA minimum element guidance for SBOM included a reference to software identification SWID tags, and he said, I believe those are different from SWHID. Steve, the answer is yes. SWID tags are an SBOM format that predates SPDX and CycloneDX. So it's another SBOM format, and it's essentially a parallel but much less used format such as SPDX or CycloneDX. It's the third format that they accept as the NTIA minimum elements guidance. No doubt, SWHID is going to start appearing in policy soon, though, and that's something we will actively try to support. Thomas,
If I may, Shane, the
yes.
first step is computing it, right? Download the tool. There are a couple. Download it, compute your software hash ID, and then play with it. Modify files, change stuff, and see, how powerful it might be, or why do you find different hash ID on circumstances that it should be the same, and then start asking questions. You have the software hash ID .org mailing list, and start asking questions there on the why. So you get familiar with. I mean, this is for many people. This is the first time they will work with something like this. So you first have to get confident that if you start introducing this into your processes, this actually works. And you obviously we we are in the phase in which other organizations are using software hash ID. So I'm sure that there is a growth there to be made. Uh, but the use case that software heritage can put on the table is huge. So if it works for them, uh, it will work in many use cases for others. Obviously, the tooling will improve over time. Software heritage now has it's uh, looking at it since the beginning. It seems that the storage part is already quite mature, and now we are in the usage part, right? In the share and usage part at scale, which is a huge challenge also. So, but I think software hash ID, especially for the industry, is a vector of of using all this public effort, but also on contributing to it. And 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 yeah, it works internally with your private code, and I think that's a killer application for any company.
Thank you, Augustine. And I think that's a good note to end this on. There's something out here that's outstandingly powerful, and the team is right here in France, ready to talk, opening things up, making Python scripts so we can play with it. Thomas, thank you for coming today. It has been a
Thank you for
genuine
your.
pleasure. And you mentioned
Thank you.
you were new at Software Heritage. So we're looking forward to playing with you for the next 10 years.
Yeah, thank you. I hope so.
Right, everyone. Thank you for
Great
being on the
talk.
call.
Thank you.
And Katharina, I'll see you in 2 weeks.
Yes, yeah, and we will miss Mattia. But yeah, thanks for the talk. That was very, very interesting and insightful. Really appreciate. And also Shane, I mean, I'm on and off on this calls, but the content and the quality that you provide is just very, very good. It's so helpful. Thank you.
Oh, you're most welcome. Everyone, those of you who'll be in Japan, see you then. Those of you who won't, we'll send you photos. Those of you who will be here next year, make sure you do. Take care all. Good day. Bye-bye.
And bye. Have a
Bye
nice day.
bye. Enjoy.